Okay, thank you. We are ready for the third slot of presentation. So the next startups will be Biosolids, presented by Giovanni Venturini.
Thank you, Giuse. Hello. Good evening. I'm Giovanni Venturini. I'm the CEO of Biosolids. I'm the guy who got the book. And yeah. So when I've been invited to participate to mine the bridge in Intesa San Paolo here in Silicon, actually I was supposed to pitch for another company. It was a biofuels company. It was a project company based on the cultivation of that crop. It's called jatropha. But in the meanwhile, we have been able to make an exit, so we sold the project. So why I'm here? I'm here because we have a much more interesting opportunity, much more profitable, much more scalable. It's a technological company. And the reason for this is that we have been able, after 2 years of work, together with the guy on the right, which is Roberto Crea, which is one of the most successful scientists in biotechnology, we came out with the right perspective, how to increase dramatically the value of the fruit of jatropha. So my background is really in developing jatropha projects all around the world. I set up 5 companies, 5 biofuels company in some African countries, but also in the Dominican Republic. I'm also chairman of the Association of Jatropha Book, which is a kind of Facebook of the sector. And Roberto Crea, of course, I don't think you have to spend a lot of words on his behalf. So what we do basically, we focus on the fact that jatropha is considered a kind of wonder crop because it produces an oil that is very suitable for the production of biofuel, for the aviation sector, for the automotive sector. So there are already plus than 1 million acres which have been planted with this crop, and they are growing, like just in 4 years. So me and Roberto, we decided to focus on another side. We decided to focus on the byproduct of jatropha, which we believe they bring the most of the value. Because from the byproduct of jatropha, we are able to produce a protein meal, basically, from the solid part, which can be used, which can be addressed to the protein meal market, which is a 100 billion market today, as well as pharmaceutical compounds. So why we think our solution, our technology will have really a big impact? Because we focus on 80% of the volume, of the mass of the jatropha fluid. Like everybody is looking just at this 19% of oil, how to bring the most of the value from it. We focus on the remaining 80%. So by using our technology that we can sell to jatropha producer like my company that I sold, like they can increase their profits by more than double, because what they before were selling as fertilizer, this seed cake, okay, now they are able to sell as animal protein meal, and also for pharmaceutical compounds. So these are our economics. We believe that the business model to go on is to ask for a royalty for each ton of protein meal which will be sold on the market. We look for $500,000 now to accelerate a process that we are already into, and then $3 million to scale up to set up the assembly line, and then to sell actually the first plant. Actually, we got already two clients that are entering into a licensing agreement. So this is basically the end of my presentation. We believe, I would like to add one sentence to the one that you can read. I believe that this technology not only will have an impact on the biofuel sector. I strongly believe that this technology will have an impact on the protein meal market as well. Thank you very much for your time. Oh. By the way, this is the product in case you like to taste one day.
Thank you. Okay, so now Lorenzo Fagiano will present his startup that is Kitenergy.
Okay, so Thank you. Good afternoon. I'm Lorenzo Fagiano. I'm a development engineer and co-founder of Kitenergy. And Kitenergy is a new company that aims to develop a new kind of renewable energy. You know, energy generation is the most critical problem that mankind is facing nowadays. What we want to do at Kitenergy is to exploit a yet unexplored source of energy that is high-altitude wind. Why high-altitude wind is interesting? Because wind speed grows with the altitude from the ground, and also the wind is more constant, and the power you get grows with the cube of wind speed. Meaning that between 600 meters and 1,000 meters, that is where we aim to produce energy, you get easily 8 times the power of a wind turbine operating in the same site. And of course, a wind turbine cannot reach those altitudes, so what we want to do is to use wings or kites, very highly efficient, equipped with onboard sensor for feedback control. These kites are linked with 2 cables to the ground. On the ground level, the cables are rolled around drums. The drums are linked to electric generators. In the first phase, the wing flies very fast in crosswind direction, pulls the cables, which unroll, and drives the generators to generate electricity. And then we have a rollback phase in which we spend some 10% of the energy we previously generated to recover the lines. And we do a cycle in this way. What we did so far, we started in 2005 as a university experience. We built the first world prototype of this kind of generator in 2006, first operating 20 kilowatt. We compared theoretical analysis, numerical analysis with experimental results, obtaining a very good matching. And we analyzed the large-scale production of energy with Kitenergy, and actually what came out is that the cost of energy produced with Kitenergy can be competitive and lower than fossil fuels without the need for incentives like feed-in tariffs. Practically everywhere in the world this can be applied. And so that's why we call this a breakthrough, a revolution in renewable energy generation. Of course, the market we address is the market of energy, ever growing, ever increasing, plus 50% projection in 2030 due to the development of China and India. And we have strong partnerships with high-tech Italian companies, Modulway and Chesi, dealing with controls and mechanical engineering. Politecnico di Torino is one of the biggest technical universities in Italy, and we have technical sponsors like National Instruments, that is a manufacturer, a very big manufacturer of instrumentation and control devices, and DSM, which is a very large company producing the cables, high-tech cables for our technology. And we are part of the Airborne Wind Energy Consortium that is growing every year, dealing with high-altitude wind energy. We analyzed all the competitors in the market, both more traditional renewables like wind, solar, and hydro, and other concepts of high-altitude wind energy. So Makani Power here in California is an example, and we think we have competitive advantages under a lot of different aspects. So the model of our business is that we develop the technology, we develop the intellectual property, and then we license the technology to companies, for example, working in the energy sector that wants to build and buy the generators. So we don't want to construct the generators ourselves. What we expect is that with sufficient funds we can have a break-even point in 4 years. So it's not a technology that's going to come in 50 years like nuclear fusion, for example, and the turnkey price of $1,000. What we seek is $6.5 million in the next 18 months to do a first industrial scale generator that will definitely demonstrate the technology. And that's all. Thank you.
Thank you, Lorenzo. So the representation of this slot will be Smania, and Silvia Bossi will present it.
Okay, so the problem that Smania wants to address is to increase the quality of life of upper limb amputees. Upper limb amputees need hand prosthesis which should be fast, easy to use, intuitive. it should give sensory feedback, and it should be dexterous. However, the currently available hand prostheses are not satisfying all these requirements. So the problem is that there is a missing link between the brain activity of the amputee and his or her hand prosthesis. A solution to this problem can be represented by the insertion of microelectrode inside the peripheral nervous tissue of the amputee. This is what we call neural interface. So let me show you a video which summarizes the results of a previous research project where also the group where I worked was involved in. This was at the end of 2008. Oops.
I had a car accident in 2006 caused by a drunk driver. My car turned upside down and I lost my left hand and forearm.
4 miniature electrodes were surgically implanted in what remained of his left arm. These electrodes helped him recognize and control the biomechanical hand. The prosthetic itself was not implanted, only connected through electrodes.
At a mental level, it's very stressing. I needed to concentrate. I needed silence. Then I said to myself, you can wiggle the fingers, you can pinch, you can clench a fist, you can open your hand, you can just do that.
The $3 million project was funded by the European Union and took 5 years to complete.
When I succeeded in closing the hand, I felt like I scored a goal at the last minute. It was such an important moment. The researchers looked at me and I understood that we made it.
Next challenge, connecting a patient's nervous system and prosthetic limb for years, not just a month.
Well, so the challenge is to increase the lifetime of these devices in vivo. And the Smania products wants to address this challenge. We developed several prototypes of a smart neural interface which combine traditional materials with smart materials. And this is a new strategy to arrive to this goal. So we have patented technology in this field, and we have also other patents which are under the deposition process. So the current market is represented by the research centers which are involved in neuroscientific tasks, and they ask for neural interfaces for scientific purposes. However, when the neural interface will be ready for the human market, we can have more than $3.2 billion market. Our competitive advantage is, most of all, is the lifetime, the increased lifetime of the device. We can also provide a good and optimal signal quality. And we can also give high structural and surface biocompatibility. We are also working on additional surgical tools in order to facilitate the insertion of the neural interface inside the body. So our team is composed by myself, and I worked in this field during my PhD studies, and Silvia, which is a professor in this field and also an opinion leader in this field, and Riccardo Moni, which has an MBA and is helping us with the financials. So with a total funding needs of $3.2 million, we plan to arrive to the human market in 2015. And to become profitable in 2016. Thanks for your attention.
First question's for Giovanni. Your co-founder was a co-founder of Genentech?
Yeah.
Right. I understood that to be Bob Swanson and Herb Blair.
Sorry?
I only know of two of the founders of Genentech.
Well, he's a scientific co-founder of Genentech. I mean, if someone can tell me he's not sure, I don't know. Actually, he's from what I know about him, he's one of the most successful scientists because of this one of these event, but not only.
So
Also
I
others.
just wasn't aware of another event.
Tim just is the one here, so you might if you want to be later.
Okay, great.
Yeah, I have a question about the jatropha.
Yeah.
I would like to know whether you need lots of water and fertilizer and what kind of climate. And I also have a question for Kitenergy. How much energy can you get with one generator, and how large of an area do you need for one?
Okay, so we made, like in the last 5 years, we made a huge number of pilot plantations. So we plant in Morocco, Senegal, Ghana, Cameroon, and many other African countries. So really to evaluate where exactly the plant can grow. Okay, after 5 years of research, we have come out with a yield curve. So jatropha can grow in even in presence of 500 millimeters, which is quite low. Okay, but in order to get some good production in terms of seeds, okay, you need to increase, and the optimum, okay, in terms of a rainfall. If your question is regarding the rainfall, it's in the range between 800 and 1,000, 1,100. If you go more than that, I don't think that you should plant jatropha. You might plant something else, which might be much more productive. So the target for the jatropha plantation is the transitional savanna, for example. So it's where no other crops can really grow very well.
Yeah, thank you for the question. So a single unit on the full scale will be from 2 megawatt to 5 megawatt rated power, with a quite large wing, and arranged in wind farms, the density per kilometer square would be 16 of these units in a good windy site. To give a thermal comparison, the average power generated in a year would be 6 to 7 times higher than wind turbine farms. Another term of comparison, if you think about a nuclear plant has a 1 kilometer high, 5 kilometer radius, no-fly zone around it. In the same volume of area occupied, we could generate 1.5 the average power of a nuclear plant.
Now, do you know how high up can these things go, and do the lines get twisted up there, and does it matter? And I mean, I got 1,000 questions.
Yeah, I can answer to all 1,000, I'm sure. And so the altitude range is 600 meters to 1,000 meters. It's already interesting. In this altitude range, in a good site for a wind turbine, we can generate twice the energy in a year. That means even with the same cost, half the cost of energy. In a bad site for actual wind, like North Italy, Pianura Padana, and zero wind at up to 200 meters. In this range, we have the same wind as in the Netherlands for a good site for a wind turbine. The other question about the twisting of the cables, control can be done efficiently, even if the cable are twisted twice or thrice, and the automatic control system is such that the cable are never twisted. So there are optimal paths for the kites that are figure-8 paths, like kite surfers do, and then that avoid cable wrapping. And another possibility is to have a single cable concept that we do not pursue for safety reasons, but it's another opportunity to have a single cable and control on board of the kite.
Lorenzo, have you done accelerated lifetime testing, and if so, how long do these devices last?
We didn't do lifetime tests so far, but we know the lifetime of each component. So the wing we are using right now are just commercial power kites, so we don't expect them to last a lot. But specifically designed wings for that could last, we think, a couple of years. We know about the cables from Dyneema, who is technical sponsor, provide the cable to us. Also, the cables are probably going to last a couple of years. So we don't expect to have a critical issue there.
Sylvia, do you have a new, I mean, I could see how that might work in one instance, but then if the arm's severed in some other way, you have to send the brain a slightly different message if it's above the elbow and below, and if your leg is cut off. I get the feeling that each of these is going to have to be very specifically done to very specific things.
Yeah, in fact, there is a training phase after the implantation, which is for sure necessary in order to address all these individual requirements. Yeah.
And how much would it cost if I lost a hand? How much would it cost me in 2016 to put one of these things back?
So each neural interface, the price that we plan is $1,000, between $1,000 and $1,500. $1,000, depending on the type of the electrode, and consider that an upper limb amputee needs at least 4 of these devices. So
$4,000. I was expecting you to tell me it was 100,000.
No. Then there is also, because this is only the neural interface, then there is the hand prosthesis. So, and of course, we are using micro technologies, so we can produce several interfaces with one single process, and that's why we can reduce the prices.
So it is generic. I mean, since you do the neural interface, it doesn't matter where it is.
Yeah, it can matter. Yeah, depend also from the age, for example, of the patient. So this maybe can matter because we would need to create new masks for the technological process. However, this is not a big expense.
I also could see a younger person being able to do this. He was a pretty young person. Yeah. And old dogs have a harder time learning new tricks. I'm just wondering if you think that this is going to work on older people.
Yes, even if, of course, in order to have this, to accept this technology, you should be really energetic, and you should have the energy to train yourself to learn to use these devices. That's why I only considered 55% of the upper limb amputees, which have an average age lower than 70 years old.